Hello, this is Dr. Quevedo. Thank you for watching. In this video, we will solve a relational algebra query for the schema that we define for the political party database. So then let's go into the query itself. So the query that is listed in this exercise, it says find the names of the members older than 40. What we need to be doing is looking into where the information that I need to display is being stored, in which of the relationships. There will be relationships that we not need to answer this. So for the first part about names, the names of the members are in the relation members. It's also talking about older than 40, so that will be related with attribute age. So that's still the table members. But now there it says that they have been involved in incidents. To be involved in an incident, the social security of the member needs to be in the table involved. So the social security needs to be there. But then there is a key here that says all. So I'm going to circle that in the query. So here it says all incidents that occur on a specific day, which in this case is November 11, 2011. So the incidents have a date. So I'm just going to go and highlight that part there. So table incidents, I'm highlighting the part that says date. So there is the information. So far, I see the information that I'm looking for to answer the query is in 3 tables: members, incidents, and involved. Now I need to decide which of the operators that we know from algebra are the ones that are going to help me. That's why I also identify that there was a key about all when it's talking about all, and that goes to division. So just going to have the division symbol there because that key that says all incidents involved on there. So that means what I'm going to be looking is finding from table incidents, all the incidents that occur on that specific date. And then I'm going to be looking for the social security that are involved in all those incidents, not in 1 or 2 of the incidents. If there are 5 incidents on that day, it has to be in all 5. Being in 4 and less than 5, it doesn't classify for the all in the case of the division. So that means I had to do a division between the relation involved and incidents. If we also review the characteristics for a division, the table that we're going to use in the divisor, which is incidents, has to be a subset of that. So right now, they don't qualify to do the division because we had to do a pi operator before. Let's do on a T1 the identification of all incidents that happened on November 11 of 2011. So I need to open the table incidents. From that table incidents, we're going to use a sigma to select date equals, then I'm going to put here 11-11-11, then closing the quote. So I'm selecting incidents from that time. Now, we say that to be able to do the division later, I just need the IID because that has to be a subset in involved. So then here we're going to enclose this in parentheses and I'm going to do a pi on IID, and finally I'm going to assign that to T1. So T1 has the identification of all incidents that occur on November 11. We need to find the social security of those that has all those ID numbers. So for that, we're going to use involve. But involve, we only need, so we need to do a pi on the social security number and IID. Now, from this, we're going to divide this by T1. T1 has only the IID, so when we do the division of the social security number, IID and IID, remember, we just going to get the social security numbers. So now here, we're going to make an assignment to a T2. So let's follow the sequence. T1, one more time, it says we found the incidents that happens on November 11, 2011, and I just got the identification number of those. Now I open the table involved, and I only getting the social security and identification of all the incidents, but when I do the division, it's going to give me an answer of a list of social security numbers of members that participated in all incidents. That's the idea of the division. So that's in T2. T2 is still not the answer because the answer says the names. So T2 is a list of social security numbers. The names are on table members. To get the names from there, what we need to do now is to do a join and see which social security numbers match the ones that are in T2. But there is an additional restriction in the query. The query says that it's not any members, it has to be members that are older than 40. So I did my T1, I did my T2, which is my second expression. Now the final one that is going to be my answer is I'm going to get the members, I'm opening table members, and then from those members, I'm selecting, that's what I'm using here as sigma, I'm selecting the ones that age greater than 40, so only those members. Now we're going to use a join operator. So now we're going to join this with T2. T2 is a list of social security numbers. So the members that match the social security numbers there are going to be displayed. But it says here that I want to see only the names. So then here we're going to enclose this in parentheses and we're going to do a pi that says projected on name. And this will be the answer for the query. So we just illustrated the process of how is that we open and manipulate the information that is in the table given the operators that we have. So what you need to remember is you need to identify the operators from relational algebra that best match what the manipulation that you had to do with these tables. Thank you.